Friends, welcome to my YouTube channel. Dhanesh here. Another interesting session on machine learning. Today I am going to discuss about p-value and significance level. A comparison between p-value and significance level. Let's start. Let's start with a quote from Michelangelo. Every block of stone has a statue inside it, and it is the task of the sculptor to discover it. Michelangelo. Let's continue. P-value versus significance level. This is from statistics. Before getting into p-value and significance level, I am giving a quick introduction to hypothesis testing. A statistical hypothesis is an assumption about a population parameter. You are familiar with these aspects, I believe. We have separate videos on the playlist. You can watch these hypothesis testing and all. This assumption may or may not be true. That is a statistical hypothesis. A hypothesis testing is a statistical method that is used in making statistical decisions using experimental data. That is a hypothesis testing. There you use experimental data. Hypothesis testing is basically as an assumption that we may make about the population parameter. You know this. This is really important. Null hypothesis and alternate hypothesis. I have separate video in detail about these two aspects. You can watch under the playlist statistics and feature engineering. Null hypothesis denoted by H0. Null hypothesis is a statistical hypothesis that assumes that the observation is due to a chance factor. Very important. Due to a chance factor. Alternative hypothesis denoted by H1. It shows that observations are the result of real effect. Real effect meet experiments. So that is, alternative hypothesis, H1. Now we are getting into p-value. It's also known as probability value. A p-value is used in hypothesis testing to help you support or reject the null hypothesis. Based on p-value, we will support or reject null hypothesis. The p-value is the evidence against a null hypothesis. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis. This is a perfect table to understand p-value better. If p-value is small, alternate hypothesis is strong and you need to reject the null hypothesis. If p-value is high, you should reject the alternate hypothesis. This should be weak and null hypothesis is strong. This is perfect. You can understand what is p-value and example. See, let us consider the example of lifespan of a group of people after a lifestyle change. See, we are analyzing the lifespan. We are analyzing the lifespan of a group of people after the lifestyle change. If the lifespan is greater than the original, let's say the original lifespan is 75 years, and after the lifestyle change, if the lifespan is greater, your hypothesis statements, this is the meaning of null hypothesis and alternate hypothesis. Null hypothesis means no change. We are taking it as H0 is equal to 75. That is null hypothesis. The alternate hypothesis is lifespan has increased after the lifestyle change. This is an example. So we are, depicting these values in the case for p-value in the right tail test. See, you need to understand what is right tail test, what is left tail test and two tail test. I have separate videos in the playlist statistics. You can watch it. See, graphically the p-value is the area in the tail of the probability distribution. This area, very important. P-value is this area. This is the tail of the probability distribution. This is, this is a normal distribution. Normal distribution, we call it as normal, or we call it as Gaussian, all are same, or bell curve. So this is the normal distribution curve. This is a bell curve or a Gaussian distribution. So the tail of this area, this is the tail. This is a right tail test. That's what I have taken only this portion. This is, when we shade this area as well, this is a two tail test. It is, the area, this area is known as the p-value. See how we will get this critical point. That's the your we have explained in the previous videos as well in right tail test. That is the z-score. Z-score, you know this, right? Z-score, separate video is there in the statistics. You can watch it. Z-score, this is the C-score, or you can use IQR score. All these, mathematical, things we are using in, outlier detection. So this critical value we are getting from the Z-score. This is known as the critical area. This we call it as the critical area, and this is the confident area. That is the statistical terms we use here, confident area. So when you run the hypothesis test, this area is the p-value. You understood that. So when you run and it is the area is right to the hypothetical, in the right of the test type statistics. So this is a right tail test. So I will give you more idea. Let's consider this two tail test. So two tail test means this is the condition. This will give you complete idea. For a two-tailed test, see these two areas it will come. The reason is for the the null hypothesis, we have taken the average, it is equal to 75. This what is mu? The lifespan, it is the 75. Here it is the mean, mu is the mean. This is mu, right? That is the mean. That is 75. And the alternate hypothesis won't be equal to 75. So it can be less than 75 and greater than 75. That's why we will get a two-tail test. It can come both the sides, right? It is not equal to 75 means it can come to this portion and it can come to this portion, less than 75 and greater than 75. That is a two-tail test. Now you will understand what is a right tail test. If mean is greater than 75, 75 is the lifespan in the example I have told you here. See, let's say the lifespan before the lifestyle change, it is 75. We discussed it. So if it is you are taking the average, sorry, alternate hypothesis H1 or HA denotes alternate hypothesis. If H1, in the case of H1, that is alternate hypothesis, or HA, if mu, the average value here, if it is greater than 75, this point is 75 and this is greater, the mean is greater than 75, then this is a right tail test. You got it? Now I think you understood. Now I am coming to the left tail test. Then that means the mean, this mean is less than 75. Then 75 will come here, somewhere here. Here we are plotting the age, right? This will be around, this is 55, this is 35, like that. You can plot the age here. So this is the z-score. This is, this area we call it as the left tail test. So this is the p-value for the left tail test. What is p-value? P-value is that area of that, this critical area we call area of that critical portion. We call it as the p-value. You understood? I think you are getting the point. Now the conclusion, this is the conclusion, a small p, that means less than or equal to 0.05, that means 5 percentage. 0.05 means 5 percentage. Reject the null hypothesis. This is strong evidence that the null hypothesis is invalid. A large p, that is greater than or equal to 0.05, that is 5 percentage, means that the alternate hypothesis is weak, so you do not reject the null. That's the conclusion about the p-value. I think you are clear on this. I explained it, I tried at my level best. You understood, I believe. Now I am getting into the significance level. It is denoted by the Greek letter alpha. Significance level. This, what is the difference between significance level and alpha, I'm sorry, p-value? The significance level is the probability of rejecting the null hypothesis when it is true. This is really a good definition. It is probability of rejecting the null hypothesis when it is true. For example, a significance level of 0.05, that is 5, indicates 5% of risk. 5% risk of concluding that a difference exists when there is no actual difference. Once again, a significance level of 0.05 indicates a 5% risk of conducting that a difference exists when there is no actual difference. Lower significance level indicates that you require stronger evidence before you will reject the null hypothesis. To graph a significance level of 0.05, we need to shade the 5% of the distribution that furthest away from the null hypothesis. If you want to plot it in the graph, see this. For example, if we want to plot 5% of significance level, we will take this area as 0.025. This area is also 0.025. Then the total becomes 0.05. We call the shaded area the critical region of the two-tailed test. This shaded area, we call it as the critical area. Critical region of the two-tailed test. This is the critical point. This critical point is we are getting from the z-score. Z-score, IQR score, box testing or whisker testing, all these things. You have videos. These are very important facts in outlier detection and statistics. Fine. So you understood that. Now, what is the difference between p-value and significance level we are comparing? If the p-value is less than your significance level, you can reject the null hypothesis and conclude that the effect is statistically significant. In other words, the evidence in your sample is strong enough to be able to reject the null hypothesis at the population level. This is the final idea. You can get it from that. This is really important. If the p-value is less than your significance level, you can reject the null hypothesis and conclude that the effect is statistically significant. Now, type 1 error and significance level. What is this type 1 error? And you are familiar with the type 1 error. We have videos for type 1 error, type 2 error, everything. The most common significance level is 0.05 or 5%, which means that there is a 5% probability that the test will suffer a type 1 error by rejecting a true null hypothesis. You understood? The most common significance level of 0.05 or 5%, which means that there is a 5% probability that the test will suffer a type 1 error. Only 5%. Type 1 error by rejecting a true null hypothesis. The significance level conservatively translates to 90% level of confidence. See, 90% is in the confidence level, meaning that over a series of hypothesis tests, 95% will not result in type 1 error. That is the confidence level. That area is known as the confidence area. See, this area, we can call it as the confidence area. This area. This is the critical region. This is the confidence region. You understood? Okay, so this point is also really important. The most common significance level is 0.05, which means that there is a 5% probability that the test will suffer a type 1 error. The 95% we are confident that is coming under the confidence area. It's not in the critical area. This is also a very important point. If the p-value is less than your significance level, you can reject the null hypothesis and conclude that the effect is statistically significant. So that's all I believe. That is okay. One more thing: p-value versus significance level. This is the final conclusion. If the p-value is greater than alpha, you assume that the null hypothesis is true. This is very important point. If the p-value is greater than alpha, we will assume that the null hypothesis is true. If the p-value is less than alpha, you can assume that the null hypothesis is false. Then what do you do if the two values are very close? For example, maybe p-value is 0.06 and alpha is 0.0. They are very close. Then it's your call to make. In those cases, you can always choose to collect more data. That if they are very close, you need to collect more data, and you need to again analyze it. The point is, if the p-value is greater than alpha, if p is greater than alpha, you can assume that null hypothesis, that is H0, is true. H0 true. If p is less than alpha, you can assume that the null hypothesis is false. This is the concept. This is a very important point you need to understand. If both of them are very close, you need to collect more data and you need to continue the analysis and experiments. So again, the summary: alpha, the significance level, is the probability that you will make the mistake of rejecting the null hypothesis when in fact it is true. That is the alpha. The significant level is the probability that you will make the mistake of rejecting the null hypothesis when in fact it is true. The p-value measures the probability of getting a more extreme value than the one you got from the experiment. That is the p-value. You know that it is the area of that, critical area. The p-value measures the probability of getting a more extreme value than the one you got from the experiment. If the p-value is greater than alpha, you accept the null hypothesis we discussed. If it is less than alpha, you reject the null hypothesis. Here we discussed, if p is greater than alpha, null hypothesis is true, h0. And if p is less than alpha, h0, null hypothesis is false. So that's all about p-value and the significance level, all important concepts in statistics and machine learning. Thanks for watching. Please like, share and subscribe. Thanks a lot.